Hello and welcome to today's lesson on listing and basic combinatorics. So, though combinatorics is quite a big word there, what does it mean? Combinatorics is a really fancy mathematical way of saying let's count things, let's count how we can do things basically. So this is probably quite a new concept to most of you. So to start with, I've taken a question from a previous paper and I thought we could start by me showing you how you'd work through it. So let's read the question. Sally has 3 tiles. Each tile has a different number on it. Sally puts the 3 tiles down to make a number. Each number is made with all 3 tiles. How many different numbers can Sally make? As this is a question, let's go through and highlight the important information. So we've got 3 tiles. Each tile has a different number on it. That is quite important and I'll explain why later. But Sally puts the 3 tiles down to make a number. Each number is made with all 3 tiles. And we want to know how many different numbers. So, where to start? This is a great example of a listing problem. That the best way to solve this problem is probably just to write out all of the possible combinations. So, we're told that we have 3 numbers, we're told that they're different. We don't know what those numbers are. We're not told that, clearly it doesn't matter, so we can choose whatever 3 different numbers we want. Let's take 3, 4 and 7. Now, don't have to have taken those, can take whichever 3 numbers I want. Could have taken 1, 2, 3, 7, 8, 9. If I really wanted to, I could have said A, B, C instead. It would not affect the result. But what we're going to do now is we're going to list out all of the possible numbers we can make with all 3 of those. So we've got 3, 4, 7, 3, 7, 4, 4, 3, 7, 4, 7, 3, 7, 3, 4, and 7, 4, 3. Now, there are 6 numbers there, can't make any others, so the answer is 6 numbers. Now, you may have noticed that I listed these numbers out from smallest to largest. I could have done it in any random order and I'd still have only been able to create 6, but the benefit to doing it in that systematic smallest to largest order is it's really easy to check whether I've missed any. So it is, obviously I haven't. So we've got 6 numbers and the answer that would get us the 2 marks is 6. So, why don't you have a go? Let's see how many different ways are there of rearranging the letters in the word plus. If you want to pause the video to give yourself more time, that's fine. But I want to know how many ways you can rearrange that. So, should find that the answer is 24 ways, that is including the word plus itself. And as we can see here, I've laid out all the possibilities in a nice table, ordered them in alphabetical order because, as I said, doing it systematically makes it so much easier to check. Here we've got plus itself in the middle in red there. We've got all the words starting with L, then P, then S, then U. This systematic ordering on a listing question is vital. It makes your life so much easier. It's so much easier to work out what's next, and it's also so much easier to then go back and check. But where does this 24 come from? Is there a better way? Particularly if we want to go for larger words, if we want to say minus, say, we don't necessarily want to list out all the possibilities. In fact, we don't. In the case of minus, there are 120 possibilities, and that's just a waste of time to list them all out. So, let's take plus again. And what we're effectively doing when we rearrange the letters is we've got a P, an L, a U, and an S. And we've got 4 sort of output slots. And we want to know how many different ways we can output them. So obviously for this first slot, so I'm going to number 1, we've got 4 options. We can have the P, the L, the U, or the S. It doesn't matter. We've got 4 options. Let's say we take the L. Then once we've taken that first slot, we've got 3 options for the second slot. We've got, in this case, the P, the U, or the S. Let's take the P. The next slot, obviously, U or the S. And the final slot is determined. It has to be the U. So we've got 4 choices for the first, then 3 for the second, then 2, then 1. And what do we do to get the 24? Quite simply, we just multiply them all out. Why? Well, if we think about it, this 3 choices we have, for every one of those 3 choices we could have chosen, there were a further 2 options. So we've got PSU. If I'd taken, I could have also had US at the end with the P. If I'd taken the S, I could have had PU or UP. And if I'd taken the U, I could have had SP or PS. So for each of those 3, there were 2 times 1 or 2 choices. And continuing that on, for each of those 4 we could have taken for the first choice, the following 3 then had a possible 6 arrangements. That's why we multiply, and you will find that 4 times 3 times 2 times 1 is 24. Likewise, if we were dealing with minus, we could just simply do 5 times 4 times 3 times 2 times 1, which you will find equals 120. Now this sort of product, as it were, this 5 times 4 down to 1, has a fancy name in maths. We call this 5 factorial. It's not unique to 5. This is defined so multiplying a number by all of the numbers lower than it is the factorial of that number. And we denote this in maths. Denote this in maths with an exclamation mark. So if I wanted to do 4 factorial, that would be 4 times 3 times 2 times 1, which, as we've seen, equals 24. So go on, your turn then. Work out the number of different arrangements of the digits 1, 2, 3, 7, 8, and 9. Don't want to know what they all are. It would take you way too long. Just how many are there? If you want to pause the video, grab your calculator, that's fine. But you should find, regardless how you did it, that the answer is 720. You can see we've got 6 digits. We can write 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Make that 3 a bit clearer, which equals 720. The more that you do these questions, you'll get familiar with the factorials. So, that's all well and good, but what if we had a word such as loop with that double O? Obviously, writing L-O-O-P there, if I underlined that O, is exactly the same as writing L-O-O-P with the O swapped. So how do we deal with that? Well, what we can do is we can break off these 2 O's into their own group. So if I quickly do that in red here. Now, there are 2 things in this group, and we know that how many different ways are there of ordering them? We know there are 2 because it's 2 factorial, which just equals 2. So what this means is that if we do the 4 factorial sum, we will have in fact counted every arrangement twice, because for every arrangement there are 2 ways of ordering the O's, and therefore we have twice as many because we have 2 factorial as many. So to work this out, we can actually do loop it's 4 factorial over, we'll scroll down, 2 factorial, which is 24 over 2, which is 12. If you want to check that, you've got L-O-O-P, L-O-P-O, L-P-O-O, then you've got P-L-O-O, P-L-O-O, P-O-O-L, and then you've got OLPO, OLOP, OOLP, OPLO, OPOL, and OOPL. And that's 12 possible arrangements, and you can check again there aren't any missing. So now it's your turn. I've got 3 numbers written out here. Go and work out the number of rearrangements of the letters in each. If you want to pause the video to give yourself more time, then go for it. Otherwise, I'm going to take you through the answers now. So, start with 9. Trick here, we've got the 2 n's. So, we're going to count each possible arrangement twice, 2 factorial times. So that's 24 over 2, which equals 12. As we saw, that's exactly the same as loop. It's 4 factorial over 2 factorial. For 12, we've got 6 letters. We've got the 2 e's. For we're going to end up with 6 factorial over 2 factorial, accounting for the repetitions because of the fact the e's are the same and the order doesn't matter, which equals 720 over 2, which equals 360. Finally, 11, we've got 3 e's this time, which means that there are going to be 3 factorial repeats, or 6 times as many answers. So that's going to be 6 factorial over 3 factorial, which is 720 over 6, which equals 120. So that's it for this video. And actually that's it for the GCSE syllabus on basic combinatorics, your listing, your product rule. That's all you really need. But it's quite an interesting topic. It comes up quite a lot in quite a few areas if you continue on to A level. And there's just more to say on it. So my next video will be continuing on, building on this, talking about combinations, permutations, and where it comes up, and the n-choose-r notation and formula. If that interests you, then please do watch it when it comes up. Otherwise, my next video for the GCSE syllabus will be on powers, squaring, cubing, that sort of thing. So thank you for watching. If you enjoyed it, please leave a like. If you really enjoyed it, please subscribe. But otherwise, until next time, thank you.